Alright, for today's video lesson, we are going to explore how we can use our counting principles, combinations and permutations to help us develop our probabilities. The situation here is we have a team of 20 different people, 5 subs, 7 backs, 8 forwards. They're all going to line up at random, which is an important part of the problem, to take a picture, and we need to know the probability that if they line up at random, all 8 forwards happen to be standing next to each other. On the surface, it seems like part A is pretty straightforward. There's one area where someone is likely to make a mistake. First of all, we have to treat the 8 forwards as if it's a singular block. So we have 8 people standing in a group plus 12 non-forwards. That's 12 different blocks. So we have 13 different chunks that we need to sort out. But that block of 8 forwards can be moved around in 8 factorial different ways. So we have to consider the fact that when we arrange these 13 blocks, which is 13 factorial, we're also going to have another 8 factorial ways of arranging those 13 blocks because of the rearrangements within the forwards. So it's very simply, we can use permutations, 13 and 8, to figure out the 13 blocks plus the rearrangements of 8 forwards, and then there's 20 factorial ways that 20 people can line up randomly. Work out the odds, and it turns out to be like a 1 in 10,000 shot. So if you just said randomly line up and you wanted the forwards to be together, you'd have a very slim chance that it actually happens at random. The other situation is, what happens if all of the forwards, I forgot to move the box up here, what happens if all of the forwards do not line up together? Let me just move this real quick for my own well-being. And if the 12 non-forwards are all lining up together, like this, then we're going to have 8 forwards that can line up in the gaps in between. They could either stand on the outside edge or on the inner gaps between the non-forwards. So if I actually counted them up, we'll notice that there's actually 13 different places where the forwards can stand so that they won't be standing next to another forward. So, to put all these ideas together, to have no forwards standing together, we can arrange the 12 non-forwards, and then we can arrange the 8 forwards that can arrange in any way within these gaps. However, and this is the big catch, there are 11 gaps to choose from, and we only have 8 forwards. So I could choose the first 8 gaps, or the last 8 gaps, or any combination of 8 spaces within the 11 gaps that we have to choose from. So once again, out of 20 factorial, 12 factorial times 8 factorial, 12 for the non-forwards, 8 for the forwards, and this is the ways in the gaps that they could choose to stand. Work it all out, and it shows out it's about a 100% or 1% chance, which is 100 times better than the odds of all the forwards lining up together. So 1 in 10,000 chance of all the forwards lining up together, whereas there's like a 1 in 100 chance of the forwards not lining up next to each other at all. So hope that's helpful. Have a good day.